I'm so excited to be here, and the topic of my today's presentation is performance scrolling. So let's start. So a little about me. So I'm Michael, and I work at OLX. I have a blog, so but you may have seen it somewhere. I also have LinkedIn and Twitter, X, how you call it. So you can also scan this QR code if you want to connect. Yeah, something like that. And I would like to start my presentation with a little bit, with some words about OLX, the company I work on, because they are great guys, I like them. So actually, I have a pretty interesting story about them. So we're pretty big company in Poland, in Portugal. We have 3 core apps, OLX, Autodom, and Automoto, and they have pretty different names in other regions. And what is interesting is that we started from having 3 big native apps written in Android, written in Kotlin and Swift. But now we are actually migrating them to Flutter, and these are very great news. This is how I got my job there. So yeah, we already rewritten the Autodom to Flutter fully. Actually, it was like a full rewrite from the scratch. And currently we are rewriting the biggest application called OLX and the second application called Automoto. And we're doing it in a pretty interesting incremental way, which makes it possible to basically add to app, right? That makes it possible to add new features in Flutter or replace existing ones with Flutter. That's it. And let's start. So this is the agenda for today, and I have 4 topics. So the first one is how Flutter renders UI. How scroll works. We will some high-level understanding of it. Then I will show you how to do the performance scroll, and we will also cover the slivers a bit. And in the end, I want to show you the apply the knowledge that we will learn, like on some common. I will show you some common mistakes and actually how to fix them easily and like performantly. So let's start. And the first, how Flutter renders UI. So actually, I would like to ask you how many of you already know these things, how they function, like widgets, elements, render objects. Okay, so I think like a half or something like that. Sure, then let me like explain it pretty fast. So you know that Flutter uses widgets, and widgets are immutable descriptions of UI. And widgets do not paint anything, they just describe it. So they're immutable, they contain final fields, and yeah, something like that. They use decomposition, so a single widget may return multiple other widgets. And based on widgets, 2 other trees are created. And there is a element tree. Element tree is the actual gray kernel that actually orchestrates these 2 trees. Based on widgets, elements are created, and when widget is returned from the build method, element is created. When widget is removed, or for example, you pop the tree, elements are disposed as well. And elements control the lifecycle. So all those methods that you see in stateful widget, in a state of a stateful widget, like dispose, init state, they are actually controlled by the element itself. And based on the widget type, the render objects are created. And render objects are those specific types of are those actual guys that paint something on the screen. So they record the painting operations, and they are able to draw the simple shapes and actually create some complex stuff based on that. As you can see, there is one-to-one relationship. There is a one-to-one relationship between widgets and elements. And but however, there is not one-to-one relationship between widgets and render objects. The reason for that is that there are 2 types of widgets. Basically, let the first type be a component widget, and the second type let it be like really like widget that describes something. As you can see, the container under the hood returns other widgets like colored box, padding, decorated box, those types of widgets. But actual like atomic widgets, colored box, for example, it describes that something should be actually colored, right? And based on those exact things that describes what to paint, actual render objects are created. And we will talk about render objects today more. The foundational protocol for render objects is called the render box. It standardizes how things are painted in a 2D Cartesian coordinate system. And the Cartesian coordinate system is that basic thing that we all learned in schools, like two coordinates, x and y, where x grows to the right and y grows to the bottom. So the start of the coordinate system is actually at the top left, where the x and y are 0. Before painting something, you actually need to understand what you need to paint, right? And for this thing, in Flutter, there is the layout process, which makes it possible to, the end goal of the layout process is to know the exact sizes of all the render objects, their positions, and so on. So basically prepare the layout to be painted on the canvas. And there are 3 core principles that actually make it possible. So the first one is the constraints go down. Again, the render object tree is, again, it is a tree, and every render object passes the constraints down to its child. And in constraints, there are 4 simple values, like minimum and maximum width and height. This way, the parent can constrain its child to, for example, a specific size. For example, you can be only 200 pixels width and height, or you can be from 0 pixels height to unlimited pixels height. Okay, the sizes go up. Based on this information, render objects do their own calculations and return the size to the, and the size can be used by the parent, right? So, for example, when a text is given like a width of, let it be 50, and unlimited height, it can calculate that, okay, for this I need like, for the given string, I need like 50 lines of 50 lines, right? And it returns this, sets its size, and this size can be used by the parent, and the parent can understand that, okay, this text is like, let it be 400 pixels high, right? And based on this information, it can, position the child on the actual canvas. However, what you can understand, this protocol is great, but it is great for things that fit into the screen, right? Because it requires the single layout pass. So what it means is that all the elements that you can see here, they should be laid out and painted. So this means that all their sizes should be calculated and so on. However, it is not suitable, it was not designed for scrolling environments, because in scroll environments, you don't have like 6 items. You have, you may have 100, you may have 1,000 items. And in such scenarios, it will be simply inefficient, because you cannot, of course you can, but it won't be efficient to lay out and paint like hundreds, thousands of elements at once, because yeah, it's just resource intensive. For this reason, Flutter has the Sliver protocol, and Sliver protocol is basically a sophisticated version that is adapted to scrolling environments. But before we talk about slivers, I would like to talk about how scroll works in high level, not only in Flutter, but in any UI frameworks. So the first component that is needed is basically a component that can understand user gestures, like when you actually swipe the screen, right? Or when you actually use the trackpad, for example, or when you just scroll the mouse. This component should be able to map this events, the scroll events, into some intents and transform it into some offset, right? So when you actually scroll like that, it should scroll like by 200 pixels, let it be. It should also understand when you scroll really fast, it should understand that there should be some like multiplier or like basically the physics that when you scroll so fast, it should be scrolled much faster. Something like that. And the second component, which we will talk more about today, this component is actually more interesting. And it makes it possible to actually render those things. Basically, it should orchestrate the whole process. And it should be able to render those. It should be able to render those hundreds or thousands of items in a lazy way, meaning it should understand the constraints, and it should be able to understand that, okay, currently the user sees only like 10 items, and it shouldn't render more than 10 items or like much more than 10 items, right? Because it will be inefficient. So in Flutter, there are two components that implement these things, the scrollable and the viewport. And usually you don't work with them often because there is no need, but scrollable exactly makes it possible to recognize those user gestures like swipes, mouse, trackpad, and so on, and convert them into some offset. And the second widget, which is the viewport, nice, which is the viewport, it makes it possible to render those actually slivers and those parts of the scroll and understand the current position which user actually sees. And we will talk about viewport much more because the scrollable is not that interesting. However, while you don't use them directly, you usually use this. You usually use these parameters like controller, physics, for example. The scroll controller makes it possible to observe the scroll state, like add a listener and so on. It contains like very rich details about the state. So the viewport. The viewport, as I already told, it's the thing that it's the actual component that makes it possible to render more component, more pixels than available on the screen, right? So if you have a content for 10,000 pixels, it won't render those 10,000 pixels at once. It will understand that only, for example, 800 pixels are visible, and it will do the work only for those visible items. What you need to know about viewport as well is that it needs exact sizes, and this is the problem that basically all of us probably faced when we started with Flutter, that when you add some list view in some column, for example, you will see that red screen or like render box overflows like by some enormous values and so on. The reason for it is that the viewport actually requires the constraints. What I mean by that is that if you have a vertical viewport, it should understand the constraints because in theory, the content inside of it can be infinite. And it should basically understand what currently the user sees. And if it's not constrained, it will basically be like a black hole that soaks everything inside. The viewports can be nested, meaning you can add the horizontal viewports inside of the vertical ones and vice versa. However, it is very logical to have multiple viewports in one direction, right? When you have, for example, a vertical viewport inside of a vertical viewport. Instead of that, you actually need to have a single viewport. This way, the things will be actually optimized and sound logical, right? The scroll views, like list view and grid view, actually use the viewport and scrollable under the hood. And what you need to know about the scroll views, like list view, grid view, is that they're performant by default. They're great. And they actually use the slivers, the viewport, and so on. And yeah, they're great for simple cases. However, there are limitations. And limitations maybe, while they're great for simple cases, like just a linear list or grid list without without collapsing a bar, for example, or without some additional details, it is absolutely great. However, those problems, like for example, here I have the list view builder with 100 of items and this 100 of items and just a simple bar. However, there are 3 questions. For example, what to do if I need to add additional list here after this one, or add additional grid view along the same axis direction, or how may I add like a section title or just another widget? And for example, about the up bar, how may I make it collapsing? For example, when I scroll, how to collapse it? These questions I would like to answer, and this is the limitations of this scroll views, because they were great for simple cases. And at this time, I would like to show you the scroll with slivers and how it works basically. So a sliver is that exact protocol, a second protocol of Flutter Flutter has that render box, and this is the second sliver that is adapted to the scroll environments. And it is the base class that render objects may implement. And it is designed for things that want to be rendered inside of a viewport, something like that. And there are 2 core things about the sliver protocol that make it different from the render box protocol. So sliver constraints and sliver geometry. So they're different from the render box, and sliver constraints are more rich and more adapted to the scroll environment. They contain like the current scroll state, for example, how far the user has scrolled, the actual dimensions of a viewport, and for example, the remaining expected remaining height beneath this widget, beneath the sliver, how big part of a sliver is actually visible, and so on. So all this data makes it possible to actually for a sliver to decide how to paint itself correctly. And the sliver geometry. Instead of using a simple size like width and height, the sliver protocol uses sliver geometry. And sliver geometry is more sophisticated and more detailed thing. Because imagine you have, again, a list with 1,000 items. What you need to do, you cannot just provide like a size, right? You cannot calculate all those widths and heights. You cannot lay out all those 1,000 items at once, because this is inefficient, right? And for this reason, the sliver geometry exists. It makes it possible for the sliver to provide the needed data for the viewport to render it. For example, whether the sliver is visible, whether it overlaps someone, the actual paint order, and so on and so on. So there are many things. We won't do deep dive into these things, so let's go next. And this is very basic layout. The viewport with the viewport. So here you can see that this gray area is the viewport. Yeah, the viewport. This is there is some image, some padding between the image, and a list with some items. So what you need to know about slivers is that there are 2 types of slivers. So the first type of sliver is actually the native sliver that just paints inside of a viewport. For example, the sliver padding. And the second type of sliver is the sliver that makes it possible to adapt render objects. By default, you cannot just add some render object like colored box, sized box, text inside of a viewport. It's because the render object doesn't know anything about the sliver protocol, right? However, there are specific widgets that make it possible to render their render box objects inside of a viewport. And for example, there is a sliver to box adapter that you can use to wrap some widget, and it will make it possible for it to actually appear inside of a viewport. And next, there is a very popular widget that you probably may not use if you're not using Slivers, but you actually use it when using like list view, because list view is basically the sliver list under the hood. And it is also it can also actually adopt the render box children. So it has those render box guys, something like that. And here I wanted to show you how you can create that layout using the slivers. And the most popular way to create the custom layout with slivers is to use the custom scroll view. It is just a widget that wraps scrollable and viewport and like combines them together, and you just pass the parameters directly to them. Here again, this is how the code looks like, and as you can see, the sliver list has very much looks very much same to the actual list. In latest updates, it actually gotten this builder and so on methods that make it possible to easily migrate actually existing list, for example. Here I wanted to show you the most used slivers. Yeah, most used slivers, and here you can see the sliver app bar. This widget makes it possible to actually render the rich app bars, for example, that are able to expand, collapse, overlap, paint, floating, and so on and so on. So there are there are a lot of properties. And under the hood, it uses I forgot the name, but some sliver. So there is some sliver render object that it uses under the hood that makes it possible to actually render widgets that want to be like pinned or stay somewhere in the viewport. The sliver padding we already discussed. The sliver main access group. This is a very interesting widget that makes it possible to group multiple slivers together, and I will show you how to use it on the case with sticky scroll headers. And the sliver grid, again, this is the same thing as the list grid view, but it is adapted to the custom scroll view. And again, the list view and grid views are, list view and grid view use slivers internally under the hood. And basically these two are pretty much the same. However, what you can see here on the right is that this list view is adapted to only those to only one linear. You can use it for only one linear list. However, what you can see on the left, you can actually add additional sliver list here, for example, with different types of elements, or a grid, or other types of widgets, and so on and so on. So this thing on the left is more flexible. This is what you need to know. And yeah, the thing on the right is also good. It is also performant, what you need, because you shouldn't use the custom scroll view. I mean, you can, but there won't be no performance benefit if you always use the custom scroll view, for example. The list view is basically the same. And finally, I would like to talk about the single child scroll view. And the single child scroll view is the thing that is actually pretty interesting. It makes it possible to make a single child scrollable. So usually it is used with some flex elements like a column or row, and it makes possible for them to be scrollable, right? However, there is one thing that you need to know about it, is that by default it is actually what it does internally is that it lays out the whole widget, because there is no other way, and actually paints it and then clips. And of course, as you may imagine, it is extremely, not extremely, but it is not performant absolutely if you have a large list, right? If you have 1,000 of items, you don't want to lay out those, you don't want to calculate the sizes for 1,000 of items, actually paint them and clip them, right? You don't want that. So in such cases, it is not very good. Actually, I forgot to say where it is useful, and it is useful in cases where usually you have some UI that usually fits onto the screen, but on some weird phones, or not weird phones, but default, but old phones, or that have low DPI, or in landscape mode, the things can change drastically, right? And in such scenarios, if you still want your widget to be responsive, if you still want your widget to actually render to be full accessible, you can use the single child scroll view. And I will actually show you the example with it. So now it's time for applying knowledge. And how much time do we have? 10 minutes? Okay. Is it okay, or like that? Nice. So let me actually run the application. So I have prepared a small app with 3 cases. I hope we will cover them all. So there is this small application, right? Nice. So as you can see, it is just a simple list, just a list with, I believe, 200 cards or something like that. I have also added as an interesting thing like performance overlay. Now you can see on the bottom the actual performance of this app. As you can see, currently this case renders in 30 requires 30 milliseconds to render a single frame. This is absolutely bad, because you need to a frame should be rendered in 16 milliseconds when you target for 60 FPS, and in 8 milliseconds if you target for 120 FPS, right? And 30 milliseconds doesn't match the math, right? So let me show you the case. What is actually going here? So there is the single child scroll view with a column with 200 items that just renders 200 cards. That is it. Again, as I told, the single child scroll view is not efficient for such large lists. So what we can do here is that we can actually use a simple list view. So let's try to do that. And actually, so we have the children, so we can just add replace the list view with the replace the column with the list view, and then remove the single child scroll view. So now, as you can see, now the frame renders in 3 milliseconds. Wow, this is the magic. So the reason for it is because list view understands that you are seeing only like 3 and actually a bit more, but it understands that you see these elements. It doesn't repaint and really out others, right? This is why it is more performant. And when you scroll, it is actually performant as well. However, in such a case, when you have some list with known items that can be with items of the single type, you can actually use the builder. And I believe everyone knows what a builder is. So I will delegate this task to Copilot. Okay. Okay. Okay, nice. So the builder makes it more performant as well, because when you're using list view, you need to actually create the instances of those widgets at once, right? And if you have 10,000 of widgets, it will mean that you will need to create 10,000 of instances of those widgets at once. This is not the best idea as well. So list view creates them on demand, something like that. And another thing I wanted to show you is about the padding. And as you can see, the padding here feels a bit off, because, for example, this scroll bar renders here, and I cannot, when I'm here, I cannot scroll down to the top actually down. The problem for it is because the list view under the hood creates the viewport, right? And what I do here is that instead of adding the padding inside of a viewport, I add this padding above the viewport. Like I wrap the viewport with padding, and for this reason, the viewport cannot just render, right? So do not do this. Do not wrap the scroll things with the padding, right? And you can just use for the list view, you can use the property that exists there, the padding property. And now, as you can see, the scroll bar renders here, and I can swipe here. Actually, for some reason, I cannot. Okay, there is some problem with tab bar. So it scrolls. And we're going to the second case. And the second case, here, on the second case, I have a bit more complex stuff, where I would like to show you the custom scroll view. And the custom scroll view here, what we have here, the some element, then we have the horizontal list, then we have again some element, then we have the grid view and actually I added probably too much items because the chunks start to be very, very big. And yeah, as you can see, yeah, so you can see that there are like 100 milliseconds for the single frame. And the reason for it, actually, let's check the case. So the case uses the list view. Inside of that list view, I have a placeholder, then the sized box, not the size box. Then I have a horizontal list with placeholder, then the placeholder, then the grid view with shrink wrap, with physics, never scrollable, scroll physics. And after that, I have a list view with shrink wrap, never scrollable, scroll physics, and it has like 1000 items. What you need to know is that while list view is performant by default, you can still make it not performant. And you can easily achieve that by using the shrink wrap property, right? And what shrink wrap property does is that it just, again, lays out all the elements at once. And again, this is not performant, right? So what we can do to fix that, I would actually like to disable the copilot because it will spoiler all the, I don't know how to do. Okay. So I would like to use this custom scroll view instead of this list view. Let's do that. And actually, before that, remember when I was talking about the viewports, that it is illogical to have multiple viewports along the main axis, like with the same axis. Actually, this case creates this. The list view will create a vertical viewport. This list view is okay because it's horizontal list. It will create a horizontal viewport. This will create a vertical viewport again, and this one will create a vertical viewport again. This is illogical, right? This should be all a single viewport. For this reason, yeah, let's go to the custom scroll view. So, so let's create the custom scroll view, and in Slivers, to render the placeholder, I will use just a simple sliver to box adapter. So as you can see now, it rendered this placeholder in a sliver environment, in a scroll environment. After that, let's add the list view, the horizontal list view. And I won't change this list view to anything else. I will just add it as it is, but again, wrap it with a sliver to box adapter. Now it renders the horizontal scroll inside of a vertical viewport, and everything is performant and great as well. Then what I would like to yeah, the placeholder. I will remove this placeholder, and let me show you the grid view. So again, for the grid view, I can use just the sliver grid. I hope it has the same signature. Yes, it has the same signature. And now, again, voila, there is a grid view. And yeah, it is actually, there are no lags, it's performant again. But the core thing was not in this thing. It was in the list view with thousands of items. And for that list view, let me just render it again. Sliver list. let it be list, right? Yeah. So now we have the list with slivers, and again it is scrolling fast, and there are no junks. Remember previously that thing rendered in like 100 milliseconds. Now it's like 4. However, what I also want to show you is that, for example, when you use this scroll bar, as you can see, there are stutters. Yeah, and the frame renders not very smoothly. And in such a case, you can actually do a bit more optimizations. Of course, if you have such a list with long elements that have the same height. And for this thing, you can use the sliver extent fixed sliver fixed extent list. And it requires the item extent. And for this item extent, I actually don't know what's the height of this thing, but let it be like 400. I'm not sure. Well, okay, wait, 300, right? Now, as you can see, as you can see, the amount of junks is much less. It is much less. There are actually more very useful APIs. There is a sliver fixed extent list, but there is also a sliver prototype. Let's check prototype extent list. Yes, and here you can use the prototype item. And as a prototype item, I will use okay, something like that. And now it will like lay out a single item, and all the items will have this correct height. That is it. Yes. Yeah. Now it renders good. Yeah. For such cases when you have something that usually has the same height, you can use such API. There is also actually a sliver. Okay, why it doesn't show sliver varied extent list, and it makes it possible to return the item extent based on such some index. So if you have like dimensions, I don't know what the dimension is, but the index, based on the index, you can actually return some. So if the index is like 0, you can return like 3. 30. But in other cases, let it be 100. And yeah, there probably should be an API like sliver variety prototype extent list, but I'm not sure. I believe it doesn't exist, but we can go further. And the last thing I wanted to show you is the third case. I have little time for it, but let's go for it. Look, okay, the third case. And the third case, I want to just create a very simple thing called sticky headers. And it's not very simple thing, but I would like to make it simpler. Just with like Flutter tools, with Flutter SDK. And it renders okay because it just uses this, the list view, and that is it. However, what I would like to use, remember I was talking about sliver main axis group, main axis group, sliver main axis group or something like that. Let it be like that. It makes it possible to group some slivers. So first of all, let's make a custom scroll view. Custom scroll view. Slivers, so it has the slivers field, and I would like to render the same stuff. Let it be the so it just renders the, what does it render? Okay, it renders the section titles. So let's convert the section titles to sliver using the sliver to box adapter. So now you can see the section titles being rendered here. And let's actually add those items beneath those section titles. So again, if you use the render box inside of the inside of the slivers, you will see this error. Let's convert it using the sliver to box adapter. Okay. Yeah, now you can see this renders. However, probably we shouldn't use the sliver to box adapter here. Let's for 20 items, let's use this sliver list. Sliver list builder, something like that, and just return the decorated box. Right. Yep. Now it. Now it. Okay, I made it kind of like infinite. Like let it be 20. Right. Now we see the same thing, right? And there is a simple hack I would like to show you. How to create a sticky header using slivers. So let's go for it. First of all, for this sliver to box, instead of the sliver to box adapter, I would like to have to use the sliver bar, which will be our sticky header, and it has a slightly different signature. So I will go for simplifying. Let it be like section like that. Yeah, it works. Let it be like that. So now these things are sliver up bars. Actually, let it give some background color. Let it be, I don't know, amber. Okay. And as you can see, it still doesn't work. And how to make it work? We need to use the I forgot the name. Sliver. Thank you. Sliver main axis group, which makes it possible to group as some slivers together, and it actually applies some magic, some math under the hood. I don't know exactly how it does that, but using this sliver main axis group, you can limit the actual sliver constraints for the sliver add bar and other slivers as well, and it would make it possible for sliver add bar to render correctly in such a case. So to be actually a sticky scroll header. So let me just put these two guys. Let me just put these two guys inside of the sliver main axis group. And for the sliver bar, I would like to add the pinned parameter, which makes it possible to actually pin something. And now, as you can see, well, there are like sticky scroll headers. It works. It is extremely simple thing, right? And there are like 40 lines of code, and there are performance sticky scroll headers that just work. Something like that. Yeah, that is it. That concludes my presentation.